To our next lesson, 10.4, Evaluating Algebraic Expressions. Our goals or our learning targets. Number one, we're going to describe an equation in words. We did that a little bit in 10.3. That's like 3 more than a number or 2 less than a number. We're going to substitute a value for x. So when you have an expression like x plus 5, we're actually going to put a number in to represent that x. We're going to also do an input-output table. We can solve problems with variables, and of course we're going to find Waldo. When you evaluate an expression, we actually need to find out the answer essentially. So we need to replace the variable with a number and find the value of its expression. In this case, I've used colors to indicate, for example, the green value. That is like, it's the value because it's equal to. The word evaluate means equal, and we're going to replace the variable. We've got to find some number to replace in this equation so that it's true. So essentially we're looking at what number added to 5 will make 20, and it's pretty intuitive, you know, with these kind of problems. Let's start off with this one. We're going to express the following in words. So you just pause it, try it. It's 2 more than a number. Now, if we have the same expression, x plus 2, and we're asked to evaluate the expression for the value of the variable given, so here's the expression, x plus 2. When x is equal to 3, we have to evaluate it. So what we do is we substitute this 3, we take the x out, and we put in the 3, because that's what it's saying here. It says when x is equal to 3. And when we do x is equal to 3, it's 3 plus 2, which is equal to 5. Always do it with words first. In this case, it's 4 more than 2 times a number. 4 more than 2 times a number. And now we're going to evaluate the expression when x equals 6. So we write it out. So 2x plus 4 when x equals to 6. So we take the x out and we replace it with 6. Now when I look at this 2x, there is an operation going on here, but I just don't know what it is because I don't see it. I don't see any operation. And when there is no visible operation, it's always multiplication. So it's 2 times x, and when in this case x is 6, so 2 times 6 plus 4. We put our equal sign on the left-hand side. Now we've got 2 choices. We could do 6 plus 4, or we could do 2 times 6. But because of BEDMAS, we should always be doing multiplication first. So you should have 12 plus 4, and you should have is equal to 16. Sorry about the handwriting. Try this one. This one's a little harder. It's a little bit longer, some more numbers added into the expression. So try and say it in words. Pause the video. This is 2 more than 3 times a number, then divided by 2. If we don't do the then but divided by 2, you will actually do 3 times the number divided by 2, then add the plus 2. So again, it's 2 more than 3 times the number, then divided by 2. That's what it is in words. So when x is equal to 4, so we rewrite this, 3x plus 2 divided by 2. But we know that x in this case is going to be 4. So we replace the x with 4. So we say 3 times 4, because remember we don't see the operation, plus 2 divided by 2. So this is 12 plus 2 is 14. 14 divided by 2. And our final answer is 7. I just ran out of room. Normally I would write that below, but I ran out of room. In words, this is, so try it by yourselves, pause the video. All right, so this means 6 less than a number. So, and you can always try it, like pretend x is 8. So it should be 8 minus 6, which is 2, which is 6 less than 8, or 6 less than a number. Now remember, there's brackets, and there's always a key word. Whenever we see brackets, we always have to use the word then. So it's 6 less than a number, then multiplied by 3. Let's evaluate. 3, we replace the x with an 8. These are beautiful numbers, I can see. You're all so impressed with my writing. And we put our equal sign. We solve within the brackets first. And again, I don't see an operation. I know it's multiplication. So 3 times 2, 6. We can also work backwards. And this is really what we're going to be doing a lot of this year. We're going to be trying to find the value of x. In this case, we're told that this expression right here, 3 times the number plus 2, or 2 more than 3 times the number, is actually equal to 11. So we can do this intuitively. We can go, oh, I could probably figure this out. Well, 3 times the number plus 2, all right, well, I have to get to 9 here, so it's 3 times 3 plus 2 is equal to 11. But there's another way of doing it. One of the things we can do is we can isolate the variable. We want to get this x all by itself. We want to have, like at the very bottom, you can see the answer. It's x is equal to a number. To do that, though, we have to get rid of all of the other parts, like the plus 2 and the times 3. And the best way to think about this is like getting dressed. You do the opposite of bed mass. Like, for example, when you get dressed, you put on your underwear, you put on your pants, then your socks, and then your shoes, right? To get undressed, you go shoes, then socks, and pants, and underwear. You go backwards. So we have to get rid of all of the extra pieces of the expression that are being added or multiplied or divided or whatever to x. In this case, we have plus 2 right here. X is being added by 2. You always do the opposite of whatever is being happening. If you do a t-chart, this is one way to look at it. X is being added by 2. That's what's happening right now. When I look at this expression, I see x is right here, and I have a plus 2, so I do plus 2. I put on the other side the opposite of what is happening. And this is what I'm going to introduce to the expression, to the equation, to get rid of that plus 2. So it looks like this. The 3x stays the same, because remember I'm doing the opposite of bed mass. Normally I would do the times 3, but because it's the opposite of bed mass, I do addition first. So it's 3x plus 2 minus 2. I can't introduce a minus 2 on one side without doing it to the other side. This is the balanced equation. We're going to talk a lot more about this in class. But this is a balanced equation. So I have to, if I introduce a minus 2 on one side, I have to introduce it on the other side. And so you're going to have 3x is equal to 9. And why do we have that? Well, 2 minus 2 is 0, and 11 minus 2 is 9. Now, what's happening to x now? We've already done, we've added we've taken away the 2. Let's look at this and assess what's happening to x right now. Well, it's being multiplied by 3.
Mr. Purview, if you are in the school, can you please call extension 600? Mr. Purview, please call extension 600.
Okay, so what is the opposite of multiplying by 3? Of course, dividing by 3. And like I said earlier, it's a balanced equation. That means that we're going to divide both sides by 3. So we have 3x divided by 3. But because we do divided by 3 on the left-hand side, we have to do it on the right-hand side because it's a balanced equation. When you multiply and divide by the same number, they cancel out. So our final answer is x is equal to 3. And you can check, you verify. Plug it in. You take this 3, and you do 3 times 3, which is 9, plus 2 is equal to 11. Oh, 11 equals to 11, it's balanced. In this way, you can do it another same sort of thing. What's happening to x